Alright, grade 9s, welcome to a new topic. Okay, acids and bases and pH value. Okay, I just need to make this little p, well, ironically I said little p, it's a capital P, but I need to make it a little p. Okay, there we go. And I should have wrote that in green. Right, there we go. Right, mistake sort of fixed. There we go. Okay, so we're going to break this topic up from into the concept of the pH value. Okay, also need to make that little p, this big P a little p. Okay, there we go. The concept of it, and we're going to discuss it in terms of chemical indicators. Okay, we're going to go there first and have a look at indicators about what that entails and basically how we can show or determine whether a substance is either an acid, base, or if it's a neutral substance. And we're going to have a look at the universal indicator and what it indicates. Okay, and then we're also going to look at the pH level or the scale, and then we're going to determine that acids actually range from pH levels 1 to 7, while bases range from the level of 7 to 14. Alright? And neutral substances actually have the number 7 in it. An example would be pretty much close to neutral would be water. Okay, another neutral substance would also be the liquid, the red little liquid that we have flowing in our veins of our bodies and other living bodies that have that same red flowing liquid. Need I mention the name? No, I'm sure we can all figure out what I mean. Alright, so in grade 7, 2 years ago, you learned about acids and bases, and this is just a quick little tabular summary of what we know about acids and bases so far. Alright, so one of the first things we know about an acid and a base is that an acid has a sour taste to it, alright, and while a base has a very bitter taste to it. So think of a lemon. A lemon would be considered very acidic because it's quite a sour taste to it. Okay. Acids feel rough while bases feel slippery. Both are corrosive. In other words, they eat away at substances, but more acid, if you get acid on your hand, just as a safety precaution, if any of you working with acids, if you guys go into your physics lab and you're doing a prac with acids and bases or working with an acid, then of course if you have if you've spilled a drop or a little bit on your hand, it's going to have a burning sensation because it's going to eat away at your flesh. All you do is you run your hand under a tap of water because water dilutes an acid. It dilutes it. Okay, that word there, dilute. And of course you'll learn that as you do physics, the actual subject of physical sciences from next year all the way through to matric, if you choose it. You'll learn that little safety precaution. Then we use what we call litmus paper, if we remember. But litmus paper is basically paper that is used to check whether a substance is acidic or whether it's a base. So we have two types, we have blue and we have red. If you dip your red litmus paper into an acid, it will stay red. Alright, so red means acid. And if you take your blue litmus paper and it changes to red, then you know you have an acid. Okay, so the blue one is kind of a bit of a better indicator because usually people render change as a more direct or more of like a in your face, like, oh yes, this is definitely an acid if it changes to from blue to red. Okay, but the opposite is true for bases. If you take a red litmus paper and you dip that in a base of any sort, the red litmus paper will change to blue. So that's how you'll know, okay, the substance is indeed a base. And then if you take your blue litmus paper and you dip it in your substance and it turns out to be a base, the blue litmus paper will not change, it'll stay blue. Okay. So if I would use, well, of course you test both, but I mean, if the one is true, so in other words, if you dip your red litmus paper in a substance and it stays red, then to check, because obviously that means it's an acid, but to check and you have blue litmus paper around, take your blue and dip it in there, and if it changes to red, then you've confirmed that it is an acid. And the opposite is also true for your bases. Now this was just vision. Okay, now obviously when it comes to mind, acids, the first substance or object that comes to mind, of course, is a lemon for me. Okay, I drink lemon water all the time, but I mean, if you ever try to take a bite of a lemon like you take a bite of an orange, of course, it's very highly acidic and it's very sour, and will definitely make your face pull in all different directions. You'll pull facial expressions you never thought you could. Okay, your eyes will probably roll back like the Undertaker, but which is very acidic. And also basically citrus. If you think of citrus, which is like oranges, grapefruit, of course, when an orange is determined to be quite sweet, if it is very, very ripe, but sometimes the orange is not ripe, it is quite highly acidic as well. Bases, if you think of any detergent that your mom uses in the house, detergent, washing soda, the stuff that they used to clean the toilets with, of course, any detergent or cleaning products would be considered a base. All right, it would be considered a base. So I hope that kind of gives a little bit of examples and that you can think of, especially in a test or exam, with regards to acids and bases. Okay, so those are some of the stuff that I have in my home. So a little bit of an activity would be to think if maybe to walk through your house tonight and check, okay, cool, so this is the substances that are bases that I have in my house, and actually these are the substances that are quite acidic in my house. Okay, acidic would probably be like vinegar. If somebody got vinegar, that would be quite highly acidic. Anything that tastes a bit sour is basically an acid, has a sour taste. Any questions so far, boys and girls? All right. The concept of the pH value, basically there's something that's called the pH scale. Okay, and of course you will learn the scale in more detail as you get to grade 10, but more so in grade 12, where we teach you how to actually work out pH values. Okay, when you learn in grade 10, we'll start teaching you something about the mole. We'll start teaching you about concentration and which is quantitative aspects of chemical change. We'll start teaching you that in more detail, and then of course grade 12 more in depth about the pH scale. But in grade 9, of course, we introduce it so you can start thinking about it, and at least have some backlog in your minds about it. But basically, the pH scale is basically a scale that is obviously used to describe basically how strong an acidic or a basic substance is. How strong is it? Okay, so it's not enough are we concerned with is it an acid or a base, but now we're more concerned to say how strong of an acid or how strong of a base is it. Okay, and the scale obviously ranges, as we saw in our mind map, from 1 to 14. Okay, now to break that up also in maybe more detail. Okay, of course we know that acids, they range from 1 to 7. Now to break that up into further detail, okay, is that with acids, the closer the pH value is to 0, the stronger the acid will be. Okay, so if a pH value renders 1, or if it renders 0 itself, alright, that means it's highly acidic. Okay, but as it gets closer to 7, it becomes weaker. Okay, so strong acids, anything I would say about 5, a pH value of 5, between 0 and 5 or up to 5 is considered to be quite a strong acid. Anything that's closer to 7 is considered weak, a weak acid. Okay, but then we come further down here, and obviously after 7 we have bases, which ranges from the pH level 7 to 14. Okay, now the closer, with bases opposite true, the closer the pH value is to 14, the stronger the base. Okay, so the strongest base would be about closer to 14 or 14, have a pH value of 14, and the weaker bases will be your closer to 7 values. Okay, so about 7, 8, maybe even 9 would be considered to be quite weak, but obviously closer to 14, I would say about 10 up. Okay, then we're definitely getting to strong bases. Okay. And then lastly, I'm just going to have to come underneath the little banner here, is that obviously neutral substances, they have a value of 7. Alright, in other words, it is neither or neither 7, no, not 7, neither acidic or basic. Okay, it's not an acid, or it's not a base, it's neutral. Okay, which is about, I would say, purified water. Purified. Tap water has got some chemicals in, but I would say purified water, so water that is, pure, just water, got no other substances in, is about 7. Tap water has about a pH level or pH value of about 5. Distilled water has about a value of 6. Alright, but I would say like proper purified water would have like a basic or neutral pH value of 7. Some textbooks say otherwise, but usually it's about 6 or 7 for purified water. Some textbooks say otherwise, but a neutral substance would be blood. Alright, that's a neutral substance. The blood in your body is neutral, believe it or not. So it's neither an acid or a base. And we'll have a look at some of those examples. I'll write them down for you before we get into a bit of chemical indicators and universal indicators. And draw about, we'll try and give a indicator with a color chart as well. And that'll probably be about like next week. And then we move on to reactions of acids and bases. And then we're almost finished with matter and materials, which is pretty cool. And yeah, we can take this topic further because acids can react with metals as well as acids can also react with a bit of non-metals as well. But if it's not necessary to learn it in our syllabi, we won't. Okay, cool. Alright, so what I do have for you here is a pH scale. Alright, very much my own. It doesn't really look like this. But basically on top here we have strong acids, 7 we have neutral, and from 7 below, or from 8 all the way down to 14, we have strong bases. Okay. So with for example of a pH level of 1 would be your stomach acid. Okay, now your stomach acid you might not know, but your stomach acid is, I mean, it serves the purpose of breaking down your food. So your food goes in there, basically it like fries, or it melts, or it gets eaten up to digest, and we've learned that in our digestive system section. Okay, number 2 would be an example of vinegar, which I said is very highly acidic. Let me just write vinegar properly. Vinegar. Number 3, this is your orange juice. Okay, freshly squeezed or whatever orange juice. Okay. Number 4 would be like your wine or coffee. Believe it or not, coffee is quite acidic. Okay. Number 5 would be your tap water. And number 6 would be your distilled water. So distilled of all those chemicals. Okay, but like I said, some textbooks say otherwise, but it's usually between 6 and 7. We'll just go with what we know here. Distilled water is pH level of 6. Okay, number 7 would be like blood. Number 8 would be baking soda. Okay, your baking soda, bicarb. Number 8. 10 would be your detergents. Okay, household detergents, like a base of 10. So if you drink that, well, let me tell you something, we have to rush to the hospital, otherwise you're going to die. And number 12 would be your dishwashing powder. Okay, dishwashing powder or dishwashing liquid. Okay, would be around your a pH level of 12 number. Okay, so that's more or less how it looks, just with a few examples of the different numbers and examples of the pH of substances that test at those different numbers. Okay, so stomach acid, very highly acidic. I think a lemon would probably have about around 2 or 3, a lemon. 2 or 3, or maybe between 3 and 4. But I mean, 0 would probably be like your highly acidic substances, like probably like a hydrochloric acid or your sulfuric acid, which is like chemically made acids mostly, but I mean obviously exists in natural form as well, of course. But stomach acid, 1, very highly acidic. Okay, you don't want to mix other substances with your stomach acid. Cool. Just to correct, maybe, because coffee has about a pH level of about 4, which is fairly, I would say, from 5 onwards. So tap water, it's quite closer to 7 than what it is to 0, tap water. So I would say coffee is considered to be acidic, but I mean it's not so far from 7 either. So I mean it's not like it's going to kill you. All right. Where I think if somebody gave you someone else's stomach acid to drink, yeah, I'm not sure how you would handle that, to be honest. But anyway, that means we as human beings are kind of safeguarded from our own stomach acid. But I mean, if there's a hole in your stomach, well, that's going to affect your body, of course. But that's for a life science section of natural science. We'll stick with chemistry for now. Okay. All right. Chemical indicators. Okay. Now, basically, chemical indicators, as I mentioned at the beginning, is used to show us whether a substance is an acid, base, or a neutral substance. Okay. So basically, an indicator, just to have a look at what the word indicator means in this regard, is basically can be any substance. Okay, can be any substance that changes color. Right, that changes color when its pH changes, or pH value changes. It's an A. All right. Now, examples of chemical indicators, and I did make one of these, by the way, when I was at school, that we do use or we can use. are universal indicators, okay, such as litmus paper. Okay, litmus paper, and of course red cabbage water, which is the indicator that I used. Okay, red cabbage water. Okay, and another one, red onion water. Okay, red onion water. Another substance that we can buy on the shelf is also turmeric water. Okay, and there is another one which I'm not going to mention now. Well, I'm not going to write down, but I'm going to mention is bromothymol blue and phenolphthalein. Actually, there we go, phenolphthalein. Which is I'm not going to put that word out. It's too big right now. I'm not going to put that word out, but phenolphthalein. Okay. Sorry, not phenolphthalein. Phenolphthalein. There we go. But the red cabbage water is the one that I think most science teachers will advocate for, because it's very easy. We just boil it. We boil the cabbage till like it's blue in the face. Take the cabbage out, keep the water, keep it in a little bottle, and then we'll throw different substances in. We'll obviously pour it out into smaller little test beakers, and then we'll obviously check if we throw a substance in there. If the red cabbage water changes color, we know, depending on the color that it changes to, what type of substance it is. Sorry. Okay. Some chemical indicators, they are made by chemists, okay, but we can make others, okay, which I mentioned: cabbage water, the red cabbage water, red onion water, or turmeric water. Okay. But most of these chemical indicators, they are not very precise. Okay, they're not very precise, and only show us whether a substance is an acid, base, or neutral. Okay, so we can obviously determine if a substance is either one of those three, acid, base, or neutral, by the color change of the indicator. Okay. Apparently in grade 7, I believe you might have used litmus paper to test, all right, whether a substance is acid or a base, okay? And of course, as we mentioned in the table, okay, if the litmus paper always turns red, okay, then we know it's an acid, especially if it's blue litmus paper and it turns red, okay? And if it's red litmus paper and it changes blue, then we know it is a base. And if nothing happens to either one of those, then we definitely know that it is neutral. Because that's why I say it's better to use the opposite colors to have tested for whether or not a substance is an acid or base. And let me tell you why. Because if you put red litmus paper into an acid and it doesn't change color, it could mean either that yes, it is an acid because it's staying red, or it could also be a neutral substance. But you test it now by inserting your blue litmus paper into the substance. And if the blue turns red, it is an acid. If the blue doesn't change color, okay, then you know it's neutral. Okay, the same way so with a base. If you dipped a blue piece of litmus paper into a substance and it was a base, and it stayed blue, it could mean it is a base or it's neutral. That's why you test with a red litmus paper. And if that changes to blue, you know it's a base. If that also doesn't change, then you know it's also neutral. Okay. Hope that makes sense to everybody with regards to chemical indicators. Okay. So what they used to do, like I said, I did the red cabbage water. Okay. Red onion is also good, or turmeric. Basically, if those substances change color when you add a few drops of a certain substance, if it changes, then you definitely know what substance you are busy working with. And I'll see if I can find a little bit of a video demonstration of red cabbage water indicator, or you're welcome to go and Google or YouTube that yourself. But if I find something, I'll put it in the group so you guys can go watch. Especially now with lockdown, I'm sure practicals are not exactly the most sought after thing. Or let me not say lockdown, but let me rather say because of COVID, it's not the most sought after thing to do at schools, because there's a lot of touching of stuff, and you know how everybody is about this little virus. So, of course, we've got to take as much precautions as possible. But, of course, you're welcome to test it by yourself, okay? Take some substances that you know you have in your house that are acidic or basic, and then test if your indicator does prove itself worthy of being called one by operating to this law that I have just explained. Okay. And I think what we're going to do, grade 9s, is we're going to wrap it up here for this week. We're going to end it here at chemical indicators. Next week, what we're going to do is we're going to go into universal indicators, as well as just have a look at the spectrum again, the colors, okay, and draw a little bit of a small table again, and have a look at the color changes of some universal indicators. So we'll have a look at the color changes of your red cabbage water especially, and I'll focus a lot on the red cabbage water since I've underlined it. Okay, yes, because that is actually a practical, and like I said, most textbooks and most teachers actually use the red cabbage water as an example, not just, don't take normal cabbage, because it's not going to turn the, or give you the same effect. Okay, so don't use normal cabbage, make sure it's red cabbage. Yeah, but I think we're going to cut things off there for this week, grade 9s. Thank you so much.